Jones. Today we're going to discuss how to graph an inequality in two variables. Now, when we graph an inequality with two variables, we graph them just like any other linear equation. So we have to solve for y to put it in our slope-intercept form so that we may graph it easier by finding the y-intercept as our starting point and then using the slope to find our second point and then drawing a line between the 2 points. So let's do that. Let's solve for y first. I'm going to add 2x to both sides. And I'm going to get 5y is less than or equal to 2x plus 10. Now, to continue solving for y, I'm going to need to divide by 5 on both sides, using the distributive property here. And once I divide by 5 on both sides, these cancel out. Y is less than or equal to 2/5 x plus 10 divided by 5 is 2. All right, now I can graph my line. But remember, if we have a less than or equal to sign, that is a solid line because of that equal sign at the bottom. So now we're going to use a solid line to graph this. But first, I'd like to start with our starting point, which is 2. And now I'll use our slope, which is 2/5, up 2 spaces and over 5. 1, 2, 3, 4, and 5. And so I will. Very nice. All right. Now remember, we're using a solid line to graph this. Now comes the point of shading. This is how we shade. We're going to test a point inside our linear equation. If the point happens to be true according to the linear equation, we shade that side. If the point we test is false, we shade the opposite plane of the line. So let's look. The easiest point to test for is 0, 0. So I'm going to test the origin 0, 0. So I'm going to put 0 in for y and 0 in for x. 2/5 times 0 is 0. Then that means 0 is less than or. If it is true, then I shade the side that the origin is on. Yes, 0 is less than 2, and so this is true, and I'm going to shade this side of the plane because the origin's right here. Shading. And that is how you would graph that particular inequality. Hello, Mr. Jones again. Today, we're still going to graph inequalities using two variables. This time we're going to graph just a greater than symbol. And so there's no or equal to there, as you can see. So that would be a dashed line. So let's take a look at it. All right. So, of course, we still need to solve for y. Let's subtract 2x from both sides. This will then cancel out. Now don't forget, this was a negative 2y when I dropped this down. It's greater than a negative 2x plus 8. Now to solve for y, I need to divide by negative 2 on both sides, using the distributive property. And I end up with y is now less than, because I divided by a negative number, a positive x minus 4. Y is less than a positive x minus 4. So let's take a look at our starting point. It's negative 4. 1, 2, 3, 4. And our slope is 1. So we'll go up 1 space and over 1 space. And don't forget, this is now a dashed line. Meaning that the line is not actually a part of our solution. The half plane that we shade will be a part of our solution, but not the actual line, because our graph is less than the line. So let's take a look at it. We're going to test the origin again. Once we test the origin is here. Remember, if the origin is true, we shade that side. If it is not true, we shade the opposite side. So let's test it. 0 is less than 0 minus 4. 0 is less than negative 4. That is a false statement. 0 is not less than negative 4 on the number line. Let's prove it. Here's 0, negative 1, negative 2, negative 3, negative 4. 0 is actually greater than negative 4. This is a false statement. We shade the opposite side. So here's the origin. We're going to shade the other half plane. And that's how we graph that inequality.